Now, students, let us understand the concept of interference through this simulations. Now, first and foremost in interference is we talk of two coherent sources. So how do we produce two coherent sources? So, and what Young's did to get two coherent sources and what were his observations? So here you can see a plane wavefront and here we have two slits. So whenever a plane wavefront is passing through these two slits, we are getting two coherent sources, and with the interference of these two sources, we can see it in the form of circle or we see it as a form of wave. These two coherent sources are interfering to give us a fringes, which you can see on the screen. And just carefully observe, as we said, when we get a bright fringe or when we get a dark fringe. So first of all, consider what we get bright fringe when the trough is with trough of other or the crest of one is with the crest of other. So here you can observe for these two waves which are coming from the source, or you can see these two waves which are coming from the different slits. When they are coming to this point, if they're out of phase over here, we can see the dark region. But here the two are in phase, we can see the bright region. So wherever you find the two coming in phase, here you can see it again, the two are coming in phase. Two are coming in phase, then at the center, observe carefully and just see. At the center, we are finding the trough of one under the trough of other. In a circular pattern, you can see all these things are coinciding with each other. So that means here we are getting a bright fringe. And wherever the two are not in a same phase, they were out of phase, there we are getting a dark fringe. It's clear? Very clearly it can be seen over here, dark fringe and the bright fringe. So this only is called as interference. Interference is superimposition. Superimposition of what? Two sources to observe the completely dark and completely bright fringes. Then we should have a coherent sources so that they have a same amplitude, frequency, and everything is safe for the two. And we can see the contrast. Now, in case of one color light, suppose if I use the light of all the colors, white color light, you say, suppose if I take a light of white color, then what pattern I'm going to see over here? Now, if you have seen the superimposition of the two gives you bright and dark fringes. Now, where the crest is superimposed with a crest, you get a bright fringe, and where crest and trough superimposed, you get a dark fringe. So wherever you will be getting crest with crest, you are getting a bright fringe. Again, trough with trough, and here trough with trough, bright fringes. Now, as I said, what will happen if I change the color? And now just keep observing on your screen what pattern you're observing. Center bright fringe was initially red. When I'm choosing the white color of the spectrum, that means when I come into the white light, I've taken all the 7 colors of the spectrum. What you observe at the center, the central fringe is what? White in color. And around that, you cannot say that at equal spacing we're getting bright. You see the bands of all the colors. Because of the difference in wavelength, their superimposition will be a different distance from the center. Different color will be superimposing at different positions. So we get all the colors. Again, I'm moving on to red color. If I move only to a red color, then I get only and only which color? Red at the center and bright and dark. But if I move to all the colors of the spectrum, white light, as I said, then for the white light, what we are getting? I'm getting a colors of all the sizes. Fine. So this was about the interference. Now let's understand another concept as I talk of fringe width. Fine. So how does a fringe width? It varies with a change in a wavelength. Now right now, suppose I'm using a light of red color and just observe on your screen the intensity pattern and the fringe width. You can see it over here. Now if I change the color, then what will be the effect on this fringe width? Let's look at the center one. This is the fringe width and this is the intensity light. You can see intensity and this is the width. If I change the color, suppose if I move to some other color, Say if I move to green color. So what will be the effect on intensity, or what will be the effect on fringe width with the change in a wavelength? We can see that with the change in wavelength, red has higher wavelength and the green has lesser wavelength. So fringe width has decreased, and you can see the intensity also. So that means fringe width has decreased with a change in wavelength. If I move to further smaller wavelength, say let's move to a blue color side, or then again observe what is the effect. It should further decrease. That means this fringe width should further decrease. So with a decrease in a wavelength, the fringe width pattern, it decreases. Next thing, let's observe what will be the effect if I change the distance of the screen. This is your screen and this is your slit. Now, if I increase the distance of the screen from this slit, what will be effect? Now you can observe, if I increase the distance of the slit and the screen, and then what will be the effect on fringe width? That is, we take it as capital D normally. So what is effect? With increase in the distance, that means we have increased the D, distance has increased, so fringe width is increased. If I further increase the distance, the fringe width should increase. That means as the distance from the screen is increased, the fringe width increases. So that means a direct relation of fringe width with the distance from the screen. Now, what is the relation between the distance between the two slits on the fringe width? Here's one slit, there's another slit. If I change the separation between the two slits, if I decrease the separation between the two slits, if I bring them closer, then what is the effect? Let's see the effect. If a distance is decreased, and you can see that the fringe width has increased, that means it is inverse relation. As you decrease the distance between the two slits from which, or you can say two sources of from which light is coming, the fringe pattern which was seen on the screen, that is bright, dark, the fringe width has increased. So that means it is the inverse relation with the fringe width. I hope it must be clear to you. Thank you, children.